Hello everyone and welcome to another Coding with Python tutorial. This is going to be the first video in a new series on 2D game programming with Python. So there are lots of tutorials out about 2D game programming in Python, and pretty much all of them use a module called Pygame. However, I recently learned about a new module that I'm currently going through and learning called Python Arcade. And in my limited use of this, I already like it a whole lot better than Pygame for a multitude of reasons that I won't get into here. I might do a dedicated video on why I prefer Python Arcade to Pygame. But suffice it to say that it is much faster and easier to use, and just in my experience, makes a lot more sense than Pygame does. So one thing to say about this tutorial, this is not a beginner's tutorial. So if you are new to Python programming, be sure to check out my beginning Python series. I will link to that playlist above right now. So check that one out first, and because you do need to know a little bit of Python to fully understand what's going on in this series. Specifically, we need to know about working with external modules, importing external modules. Specifically, if you know how to use the random module, that will help out tremendously. And if you know a little bit about declaring and calling functions, that will help out tremendously as well. For some of the later videos, it'll require at least a basic knowledge of OOP, object-oriented programming, but it will probably be a few videos before we get into that. So as long as you understand like the basics of Python, you should be pretty good to go on this one so far. So one other thing to note is that we will need a full IDE to do this, an integrated development environment. Thankfully, there are lots of great free IDEs available. You can just pick and choose whichever one you're the most comfortable with. I'm going to be going through this tutorial using VS Code, which is my preferred free IDE. I will link to that in the video description below in case you want to check that one out. But if you have another one that you like, if you want to use, Sublime Text, Notepad++, PyCharm, any one of these will work just fine, but having some kind of a code completion and highlighting and the extra features you get out of an ID will be tremendously helpful, as you will see very shortly. All right, so let's go ahead and get into this video. So what we're going to learn today is just how to draw with primitive shapes. So a primitive shape is just a basic shape: a circle, a square, a polygon, an arc. There are lots of different ones that are supported by Python Arcade. We're only going to use a few of them right now. I think we're just going to use rectangles and squares, I think, is everything that I have in this video. Oh, and circles. Wait, yes, yeah. Rectangles and circles are pretty much all that we're going to use in this one. But I'm going to go ahead and show you what we're going to do. So we're going to draw a forest scene, and we're going to have a ground and a sky and a sun. And then one of the really cool things is we're going to have procedurally generated trees that appear throughout our level. So I'll go ahead and show you what that looks like. I'm going to run my completed code. And that is our end result. So if I close that and reopen it, so as I said, these trees are procedurally generated, so every time I run this, they're going to appear in different locations around our scene. All right, so with that, let's go ahead and get started. So right now, I've got VS Code open. If you are using VS Code, be sure that you have the Python module for VS Code installed. If you don't, it's super easy. Just go down here to the extensions section, search for Python, and I already have mine installed, but just find Python for VS Code and then install that. So I can either disable or uninstall. You should have an install button. It'll just take a few seconds to get that installed, and that'll enable highlighting, code completion, and all that good stuff. And when you're done, go ahead and close that. And let's get rid of that tab. All right, so we are going to go ahead and create a new file. So I'm going to go to File, New File. And so I'm going to click Select a Language and just scroll down until I see Python. There it is. And I'm going to go ahead and save this as well. Save as. And I'm just going to call this Sunny Forest. There we go. So the next thing we'll have to do is to make sure that we have Python Arcade imported or installed rather. So the way that we do that, So the way to install that is to open up your command prompt, and you can do that by just clicking the type here to search on the bottom left if you're on a PC. And in the command line, just type pip, that's the Python package manager, pip install arcade. And mine says requirement already satisfied because I already have this dependency installed. However, if you do not have this installed, then it will install the software. It is fairly large as far as Python packages go, but it shouldn't take longer than 30 seconds to a minute to get the entire thing downloaded and installed. But once you do that, you should have everything installed and ready to go. All right, so back in our code, the first thing we're going to do is we're going to import the arcade module. So we're going to import, and actually, I'm going to go ahead and make sure I have this commented. So imports, we're going to import arcade, and then because of our procedural generation, we're going to do from random import rand range. So we're going to use the random range function in this. All right, after that, we're going to set our screen size constants. So since these are constants by convention, we'll go ahead and do these in capital letters. These will not change throughout the program. They are going to remain the same. And we're going to do screen width, and we'll just set that equal to 600, and then screen height, also set that equal to 600. So when we do this, this is going to set this in pixel values. So this is going to be 600 pixels wide and 600 pixels high. Right now I'm using my display resolution, I believe is set to 1080p. So if I set it to 1920 wide and 1080 high, that would basically cover up my entire screen. All right, so you don't have to use these values, but that's what I'm going to work with for right now. All right, after that, we are going to open our window. So we're going to go ahead and call the arcade module, and we're going to use the open window function. So, and it should, if you're using VS Code anyway, I'm not sure how your IDE will work, but it will bring up a list of arguments that we need for this particular function. And so for this one, it's we need a width, which is going to be an integer value, a height, which is an integer value, and then a window title, which is a string. Then after that, we can set it to be resizable, which is false by default, and then do anti-aliasing, which we're not going to worry about right now. So right now, we're just going to do the width, height, and the window title. So we already have our width and height set, so I'm just going to use those constants that we declared a moment ago. Screen width, screen height, and then put in a string. Of course, since that's a string value, it has to be in quotes. And I'm going to call this sunny forest. There we go. All right, after that, we're going to set our background color, and we do that with arcade.setBackgroundColors. This is another one of the arcade functions. And in the arcade module, there are a bunch of predefined colors already. So if we go to arcade.color, so on mine, it tries to autocomplete color to capitalized, but be sure you do lowercase color on this. If you do capital C color, it will not work properly. So arcade.color, and if we just start typing something in, then it will give us a recommendation of different colors to use. So this is going to be a sky. That's going to be our background. So I'm just going to type in blue, and let's do blue yonder. That should be a pretty good sky color. Of course, you can experiment with this and try a different color if you want, but blue yonder I find works pretty well for this. And after that, we need to enable our graphics rendering engine, and the way that we do that is by calling the function arcade.startRender. And that is a function. It doesn't take any arguments, but we still need the parentheses at the end. All right, so from there, if we go ahead and run this, pretty much nothing happens. Actually, it did. It opened our window, it rendered the background color, and then closed it very, very quickly. So what we need to do now is make sure that that window stays open. So we're going to scroll down a little bit, and we're actually going to go ahead and write the end of our program, which we're going to say arcade.finish render, so that finishes the rendering engine, and then arcade.run. So we need to have these two lines down here, and I'm just going to write finish program. So we have to have that in order for the window to stay open, then it waits for us to close it. So now if I hit play, There we go. We have our window. So we opened it 600 pixels wide by 600 pixels high. We have our title of the window, Sunny Forest. And then we have our blue yonder background. And that's it so far. All right, so the next thing that we're going to do is we're going to start drawing our shapes. So let me go ahead and figure out what shapes we're going to need. The first thing that we're going to need is a ground. So I'm going to write draw ground. I was going to go ahead and create these headers just so we know what we have to do. After that, we're going to draw the sun. And then after that, we are going to draw trees. So those are the first three things that we're going to work with. So for the ground, we're going to draw a rectangle that's going to be on the bottom of our screen, and that's going to represent our grass. So we are going to do one of our rectangle functions, and there are several different ways that we can draw a rectangle. We're going to use a filled-in rectangle, and otherwise you can either do a filled-in rectangle or just an outline. That's true for pretty much all shapes. You can either do a filled-in or an outline. So we're going to do a filled-in, and we're going to use a function called... So if we type in draw, then it gives us all of our draw functions. And we're going to do something called an LRTB, rectangle filled. So it seems like a mouthful. But draw means that we're going to draw something. Rectangle filled, that's our shape. We're going to draw a rectangle that is filled in, that's colored in entirely. And then LRTB means left, right, top, bottom. So basically, we're going to tell it the left side position of our rectangle, the right side position, the top position, and then the bottom side position. So left, right, top, bottom is how we're going to define this. So first, we're going to tell it where our left side is going to be, and we're going to put that all the way at the left side of the screen. So here we're going to use a Cartesian coordinate plane, and you probably remember doing this maybe as far back as elementary school or middle school, definitely in algebra and trigonometry, and if you've had calculus, you've used these a whole lot. But if you remember using like the graph, where you have a vertical y-axis and then a horizontal x-axis. So the 0 point is right in the middle, and then positive values on the x-axis go to the right, and negative values on the x-axis go to the left. Positive values on the y go up, and negative values on the y go down. Computer graphics work a little bit differently, and Python Arcade works even a little bit differently than that. I'm not going to go into how the coordinate plane works in most graphic programs. Since we're doing Arcade, I'm just going to tell you how it works on this one. So in this, our 0 point is going to be not in the middle of the screen, but at the bottom left. So the bottom left of this corner of our screen is our 0 point, and aside from that, everything works the same. Positive x values go to the right, negative values go to the left. So if we did a negative value, it would actually be off screen. And same thing for y. Positive values go up, and then negative values go down, which, of course, if we used a negative value, that would be off screen going down. And these are going to be in pixel values. So it has to be, in order for it to be to appear on screen, it has to be between 0 and 600. If it's less than 0, it's going to be off the screen. If it's higher than 600, or whatever your screen width or height is, it's going to be off the screen in the other direction. So for this rectangle, our left side is going to be at the left side of the screen, which is going to be the 0 point. So we're going to do 0. And then the right side is going to be at the far right, which right now is the 600th pixel. However, we don't want to use that. Just in case we decide to go back and change that later on, I'm not going to put in 600. I'm going to tell it screen width, which right now is 600. But if we change that to 1200 later, then it would only draw the rectangle halfway across the screen. So 0 is our left side, screen width is right side. And then after that, we're going to do the bottom. And for this, we want it to cover, or I want it to cover, the bottom third of the screen approximately. So for this one, I'm going to say screen height divided by 3. And that's going to cover the bottom third of the screen. And then the bottom is going to be 0. That's going to be the very bottom pixel of the screen. So that is my left side is 0. My bottom is, or I'm sorry, my right is screen width. My height, my top is screen width divided by screen height divided by 3. And then my bottom is 0. Oh man, that's a lot to take in. All right, and after that, we're going to set our color. So again, we're going to use arcade.color lowercase dot, and then again, there are lots of different greens that we can choose from, but I'm going to choose MSU green. So this is going to represent our grass, and that's a pretty decent grassy color in my experience. All right, so let me save that, and let's go ahead and run it and see what it looks like. There we go. So now we have our sky, and then we have our ground. That is our LRTB rectangle there on the bottom. So far, so good. All right, the next thing we're going to do is draw our sun, and for this, we're going to draw a circle. So we're going to do arcade.draw underscore circle filled. Again, we're going to do a filled in circle. All right, and for this one, we need the center of the circle on the x-axis, the center on the y, so it's just regular xy coordinates. It's going to expect floating point numbers for those, but we can put in integers. Since this is Python, we have we don't have to type our variables. We use duck typing. Looks like a duck, quacks like a duck, it's a duck. So we can put in an integer and it will automatically convert it to a float for us. Don't even have to worry about that. All right, after that, we're going to put in the radius and then the color. So the center on the x, the center on the y, the radius, and then the color. So I've already messed around with some values on this and figured out some that I like. So for our x and y, we're going to do 50 for the x. For the y, we're going to do another math equation here. We're going to do screen height minus 50 for the height. And for the radius, we're going to do 75. And for the color, we're going to do arcade.color.sunset. And again, play around with these values a little bit, especially if you're using a different screen size, and just, kind of see whatever works for you and your purposes. All right, let's hit play on that. And boom, there is our sun. Very, very good. All right. So now we get into the really fun part. We are going to start drawing trees. So on this one, we're going to do something a little bit different. So this is where our procedural generation comes in. And procedural generation has been a pretty big buzzword, especially among indie games for the last several years. Procedural generation has actually been around for a very, very long time, even back into the early computer games of the 1980s. But people are constantly finding new ways to use procedural generation. So what is procedural generation? People usually think of procedural generation quite erroneously as random generation, but it's not really random. So if you think of a really popular procedural generated game that we probably all played, my go-to example is Minecraft. Minecraft uses procedural generation, but it isn't truly random. If it were random, you would have just blocks all over the place where it didn't make any sense for them to be. So Minecraft operates semi-randomly within a set of rules or a set of constraints. So there are biomes where only like certain kind of blocks go together. There are rules for making trees and to make sure that there aren't blocks just, floating out in the middle of nowhere. So again, they have a set of rules. So we won't really get too deep into procedural generation here. We're just going to use a very, very, very basic, just a couple of lines for a procedural generation code. But if you want to know more about this, I highly recommend checking out the book Spelunky from Boss Fight Books. This is not a paid advertisement. I just absolutely love that series, and that book in particular is the best one that I've read. I will be sure to link to that in the description below. So check that book out. Spelunky is also one of my favorite uses of procedural generation. That book was written by the actual designer of the game, and he goes into great detail about his procedural generation algorithm that he used for that game, and it is absolutely brilliant in its design and especially in its simplicity. So definitely check that out if you want to know more about procedural generation. All right, so for this one, the reason that I decided to go with procedural generation is honestly, it's a lot easier than doing this myself. Same with a game like Spelunky or Minecraft. Like it would have taken an unfathomable amount of time to program that game or to do those maps by hand. And this way, the game does things that the designer may not have even thought of before through procedural generation. And really, it takes a while to program that, but it's a lot easier than doing everything by hand. So the same thing for our purposes. I could place all of these trees by hand, but then I would have to have all my pixel values and everything set exactly correctly. And I just didn't want to go through all that. So again, we're going to go through a set of constraints and just have it place our trees more or less randomly throughout the level. All right, so in order to do that, we are going to create a function called drawTree. And we're going to pass that two arguments, x pos, or x position, and then y position, colon, and then start a new block. And so we're going to make this up of two shapes. We're going to create a rectangle for the trunk and then a circle for the leaves. It's going to be a very, very simple tree, but trust me, it'll get the job done. All right, so for the trunk, we're going to do another filled rectangle. So arcade.draw rectangle filled. So this time we're not doing an LRTB. We're doing a regular filled rectangle. So for this one, instead of doing the left, right, top, and bottom, we're going to give it the center on the x-axis and the center on the y-axis, kind of like we did with our circle sun a moment ago. After that, we're going to give it a width and a height and then a color. Then if we want to, we can give it a tilt angle, so we can tilt it on the axis, which we're not going to do, so it's going to be straight up and straight down, but that option is there if you want to do it. All right, so for our x-axis, we're just going to pass it that x position variable that we created. And same thing for the y-axis, we're going to give it the y position variable that we created. For the width, we're going to give this actual numbers. We're going to give it 15 and 80. So all of our trees are going to look the same, but I'm totally fine with that. And then our color, we're going to do arcade.color. And we're going to do wood brown, since they are going to be wood tree trunks. That kind of makes sense. And then after that, we're going to draw our leaves, and we're just going to create a circle. So arcade.draw, and we're going to do circle filled again. Same thing as we did before. We're going to pass it the x position variable and the y position variable. Actually, for this one, we're going to do y position plus 25. So if we did just y position, it would place it right in the middle. It would have the same center as our trunks. However, the leaves are going to be higher up. So we don't want it like right in the middle. So we're going to do y position plus 25. So we're going to put that in the middle of our trunk and then up 25 pixels is how that works. All right, and our radius, we're going to do 35. And so whenever I was, for our color, we're going to do fern green. So whenever I used to follow along to tutorials like this, I would always get so confused at how people just knew like what perfect values to type. And it was an embarrassingly long time before I figured out that they weren't just coming up with these values off the top of their head. I experimented with this last night. I came up with this method, learned it myself, and honestly, I'm pretty slow when it comes to learning new topics. I spent about 2 or 3 hours with this last night after my wife and kid fell asleep and getting this algorithm set. So I probably tried at least a dozen different numbers before I got these exactly how I wanted them. So I always encourage you to experiment. Use different numbers, use different variables, see if you can come up with something. These numbers probably aren't perfect. You can probably come up with something a little bit better. But for me, these worked pretty well. And again, it was just a lot of experimentation that how I came up with this. All right, that is our draw tree function. We're going to add a little bit to it later, but that's going to be it for right now. So the next thing that we're going to do is we are going to do our procedurally generated tree placing sort of thing, function, I guess. I'm not technically going to place this in a function, but we can think of it like that. I might do that later. So when I originally did this, I used completely random values, more or less. And I started coming up with really, really weird behavior. I'm actually going to show you how I did this first. So I'm going to use a for loop. We're going to do for I in range 10. So this is going to loop through, it's going to go 10 times through this iteration. So basically it's going to place 10 trees. I'm going to say max y position equals screen height divided by 3. So technically this isn't completely random because I'm already giving it a rule. I'm telling it that the maximum y position that it's going to use is screen height divided by 3. Why did I use screen height divided by 3? Because that is the same level that I used for my filled in rectangle representing the ground. So by setting the max Y position to screen height divided by 3, it's going to make sure that I don't have tree trunks floating up in the air. Everything is going to be inside of that rectangle, so it's going to be it's going to appear to be sitting on our ground at least. All right, so after that, I'm going to do draw tree. I'm going to call this draw tree function. And so it's going to expect an X position and a Y position. So for the X position, I'm going to do a truly random number, or as close as we can get in Python. So I'm going to call rand range, and I'm going to pass it screen width. So for our X value, it's going to use a random range from, if you only pass it one argument, it gives it the maximum value as a, or it gives it that as a maximum value, I'm sorry, and it automatically assumes the minimum value is going to be 0. So every time it runs through this loop, it's going to generate a random number from 0 to 600, and that's going to be our pixel value on the x-axis. So on the y-axis, we're going to call another rand range, but we're going to pass this one maximum y position. Again, just so it doesn't, oops, I can tap that right, there we go. Just so it doesn't have us any trees floating in the air, it's going to be sure it places them on our ground square. And that should be good. Now, if I go ahead and run this, then it's going to print 10 random trees all around the ground. Oh, and it gave me an error. Give me just one moment. Let me debug this and see if I can figure out what's going on. Alright, we are back, and it was giving me an overflow error. It didn't like one of my variables for some reason, but I ran this a couple of times and eventually got it to work. But again, that's one problem that I had with doing it this way, is the numbers don't always behave how you want them to. And then when I ran that, you see I get some very strange behavior. Like I've got one tree that's kind of inside of another tree, which is a little bit weird, again, because these numbers are more or less truly random. And if I close that and run it again, now that one is a little bit better. Some of these trees are a little bit clustered together. Let's run that again. There we go. And again, now I've got some kind of a weird thing. This tree should be behind this one, you know. But as you do this, you'll start to see some weird behavior. Sometimes it comes out looking pretty good, and other times you get strange behavior like that. One time I did it, and like all the trees were clustered together, because when you're using random numbers, that will happen sometimes. You'll have a range where all the numbers are very close together. And even though it's random, it doesn't look random. It looks like you just placed all the trees there. So it's kind of weird, but by giving it rules to work within, you can create the illusion of more randomness. So it's kind of strange. So that's what we're going to do. So I'm going to go ahead and get rid of that whole for loop, and we're going to do that a little bit differently. So it's only going to take us 3 lines of code. It's actually relatively simple. So we're going to call again for I in range. Excuse me. And in this one, we're going to pass it 3 arguments. So when you use the range argument, it's going to expect, you can put in 1 argument, and it will assume that that is the max range, and it will do 0 to whatever that argument is. If you put in 2 arguments, that will be the minimum and the maximum. So you can do like 5 to 100. If you put in 3 arguments, then it will do the minimum, the maximum, and the step size. Let me pull up idle for just a moment, and I will kind of show you what what exactly this does. If you already know how to use random range, feel free to skip ahead. I've got chapters listed in the description below. So if you already know how the range function works, you don't feel like you have to watch this part. All right, so if you're still with me, going over the range function, let's do for I in range 10, print I. There we go. So this is 0 through 10 non-inclusive. So it doesn't count 10, but it does count 0. So when I did that, for I in range 10, basically I is just my iterator. It's basically saying call every number in this range, and then print that number. So it starts with 0. For 0, print 0. Then it iterates to the next number. For 1, print 1. For 2, print 2, and so on until it gets up to 9. Remember, this is non-inclusive, so it's not counting 10. It does print out 10 numbers, but it counts 0 as one of those, so that is very important to remember. It's not going to be very big for our tree example, because all we need is 10 numbers. They don't necessarily need to be 1 through 10. 0 through 9 will work just fine. All right, now let's try this. For I in range, now we're going to call two arguments, 5 and 10. So now before I run this, try to think about what this is going to do. So pause the video if you need to and take a moment. But now I'm going to run it. And there, now it prints 5 through 10, again, non-inclusive, just 5, 6, 7, 8, and 9. It does not print the top number. And then I can do this. For I in range, I'm going to pass it 3 arguments. 0. Actually, let's do 0, 101, and 5. So now 0 is the minimum, 101 is the maximum, non-inclusive, so it's actually just going to go up to 100. And then our step size is going to be 5, so it's only going to count every 5 numbers. So let's try that. So there, starts at 0, 5, 10, 15, 20, and so on, all the way up to 100. So that's how the range function works. All right, and so for ours, we're going to pass in a minimum, a maximum, and then a step size. Our minimum, so this is going to be where the trees are going to be placed on the screen. So, and this is actually just the X value that we're going to be working with. So we're going to start with 25, which means that the furthest to the left that the center of the tree trunk is going to be is 25 pixels from the left, if that makes sense. So 25. The maximum, we want it to be 25 in from the right side. So the maximum is going to be screen width minus 25. And then our step size is going to be 75. So the closest that it can place two trees to each other is 75 pixels. So that way it's going to prevent trees from being on top of each other in a way that looks weird and awkward and messes with the perspective. All right, after that, we're going to use the maximum Y position variable again. Same as it was before, we're going to do screen height divided by 3, and this ensures that everything is going to be on our ground rectangle. And then here, it's going to get just a little bit tricky again, but not too bad. Oops, I just realized I forgot my N. There we go, for I in range. That'll work better. All right, so under maximum Y position, we're going to call our function draw tree. And then again, it's going to expect two arguments, X position and Y position. So our X position is going to be random range. And our range is going to be I, the iterator, minus 25. And the maximum is going to be I plus 25. And then our Y is going to be rand range max Y position. So we're just going to give this one argument. So it's going to be basically a random level somewhere on that Y axis, the vertical axis. All right, so what this is going to do is it's going to start iterating on the 25th pixel. And then every 75 pixels, it's going to put another tree until we get to 25 pixels from the right side. So we're going to start at 25. We're going to end at 25 from the right side. And our step size is 75. So it's going to place a pixel every 75 pixels. And that's what keeps our trees from appearing on top of each other. So let's see what happens just out of curiosity when I get rid of that step size, when I get rid of that 25 and just do the min max. I don't even know what's going to happen exactly, but we're going to figure it out. That happens. So basically that puts a tree like every single pixel. So again, I played with these numbers a little bit. I didn't use anything that crazy, but 75 is the value that I figured out works pretty well. So we could do like 300, which is half my screen size, and then it'll only print like probably 2 trees. Yeah, we just got 2 trees there. That's it. So again, play with these a little bit. If you want a little bit of a dense forest, then you might want them that way. I just wanted them far enough apart that I knew they weren't going to be placed like right on top of each other. Like those two, like that one's okay. There we go. So again, starting from 25, ending at 25 from the right, every 75 pixels, we're going to place a tree. Then the draw tree, we're going to do random range I minus 25 and X plus 25. So that's going to give us another like 50 pixel range that a tree can be placed. Again, just so it doesn't look like everything is perfectly lined up. And then we're going to place that randomly along the y-axis. All right, so I hope that makes sense. Let's run a couple more of those just to check out our work. Yeah, and every time we do that now, I'm not getting any weird overflow errors. Everything looks great, and it looks, dare I say it, pretty random. So yeah, we probably could expand that a little bit and make it look a little bit more random, but I am perfectly happy with the way this is going right now. Hello. All right, we're going to do one final thing before we completely wrap up this video, just to help our tree and sun images pop a little bit, and we're going to add an outline around them, which is actually very, very simple. And actually, I had this pretty well completed, and my daughter E came in this morning, and she was like, "Hey, why don't you add outlines around those? That'll look a whole lot better." I was like, "You know what? You're right." So I'm going to show you how to do that. And again, that is super, super simple. So before we were using all filled shapes. Like for instance, for the sun, we used arcade.drawCircle_filled. So for this, we're going to do arcade.drawCircle_outline. And aside from that, we are... All right, and aside from that, we're going to pass it the exact same parameters that we used before. So we're going to use whatever's above it, 50, screen height minus 50. Put a space there. It's not 100% necessary, but it looks nicer. 75. And then for color, so some people like to use a darker version of the same color. So you might want to use an orange or a little bit darker yellow. However, I usually default to black. Like I try black, and if that works, I leave it, and if it doesn't, then I try to find something else. So that's generally what I do. So that's what I'm going to do here. I'm just going to leave it at black for now. All right, and we are going to do the same thing in our trees. So we're going to do this inside of our tree function. So one thing to mention about Python Arcade, and this is true for pretty much any game creation engine or art software that I know of, is that things will be drawn in the order that you put them in your code. So on this one, for instance, I drew the tree trunk first, then I drew the leaves. So the leaves go on top of the trunk. If I did it the other way, then the trunk would appear to be in front of the leaves, which would look a little bit weird. So same thing for our outline. We have to make sure we put that before the leaves, and I'm going to put that after the trunk. It can go before the trunk and it'll be fine, but I'm just going to do it this way. So pretty much what we did before, arcade.drawRectangleOutline. And then again, we're going to pass it those same parameters, X position, Y position. 15, just the same parameters I used above that for the rectangle filled. And I'm going to make that black as well, and then I'm going to do one for the leaves. Circle outline. X position, Y position plus 25, 35, arcade.color.black. Let's save that and let's run this and take a look. Oops, and I did something again that it doesn't like. Give me just a moment and let me figure this out. Oh, I accidentally did an arc outline instead of rectangle. Let's fix that. There we go. All right, now let's try this one. There we go. So now everything has an outline, and that just helps it pop a little bit, stand out from the background. I kind of like the black. If I were going to use this, I might use like a darker green or something, but honestly, that looks pretty good. And again, if I run that a few times, yep, everything still works great. All right, so if you learned something today, if you like this video, please hit the like button. Also, don't forget to subscribe and hit the notification bell. I'm going to start cranking out content pretty regularly. So I've got my RimPy tutorial series. This on Python Arcade is a new tutorial series I'm doing, and I've also got my basic Python tutorial series that I'm doing with my daughter, where I'm teaching you how to code alongside teaching her how to code. We've got a few basic tutorials up already, and we're going to get into some more intermediate and advanced territory hopefully pretty soon. And if there's anything, any questions that you have, anything you'd like me to see, or if you want me to show off some stuff that you've done, post that in the comments below. I would love to see your work, and I'd love to hear your ideas if there's anything you want to see me cover in the future. But until then, thank you so much for watching. I will see you in the next video. Goodbye.